Okay, we're live. Perfect. Thank you, Bam, for your help. Welcome, everyone. I see we have 2 people watching. I just have to remove the sound from my return. Great. As always, feel free to say hello in the comments. Say hello in the Telegram if you're already there. And we're going to start shortly. We just wait for a few more people to join us. And we're going to be able to start with today's session. Yeah, just waiting for a few more people to join. I can already start shilling the Telegram group as always. So if it's your first time here, welcome to the Plan B Labs Lightning, where the goal is to have a bi-weekly session where we cover recent developments in the Lightning Network ecosystem. It can be tools, it can be new releases and implementations, it can be specification discussions, it can be research papers, all this kind of stuff. And we also have a Telegram group, which you can join by scanning the QR code just here. And the idea with this Telegram group is that it's a convenient place for us to gather between sessions to discuss stuff, to post links about new stuff that you would like to talk about during the sessions. And it's also a good place to coordinate for various other aspects, because the idea is also to have a practical, hands-on experience with the lab. So we're talking about exercises, for example, or it can also be some projects which we try to launch pretty soon, actually. And so it's a great place to coordinate for such projects as well. So feel free to join the Telegram group. By the way, I didn't put there that they were live. Now it's done. Great. So I see that we don't have many people here yet. But I'll start anyway, I guess. Maybe I can wait a bit longer. Well, I guess people can always join us where we're at. So there are 3 main topics I want to discuss today, maybe not in this specific order. One of them is Lightning payment privacy through proxies. It's linked to a recent new prototype that SuperTestnet unveiled last week. And so we'll dig a little deeper into Lightning payment privacy and how it can be enhanced by using proxies. We'll talk about a nice tool that Elcerion developed and announced last week, which is LN POS. So POS stands for point of sale. It's not proof of stake in this context, of course. And so we'll take a look at this and what problem it tries to solve. And then we'll take a quick look at liquidity sourcing. Basically, when you run a Lightning node, either for a business, for yourself, things like that, you need to have at least some inbound liquidity if you want to be able to receive things like that. And so we take a look at Amboss's new offering, which is basically a liquidity subscription. We'll see maybe what the target for this kind of services is. And we'll take a look at another interesting thing that I saw last week, which is using Nostr to broadcast liquidity offers, basically. So creating a marketplace for liquidity, for Lightning liquidity on Nostr, which I found useful. And maybe we can then talk a bit about some kind of project that I think the lab could be a nice place to incubate. But we'll talk about that later, of course. I need to manage my effect. Great, so I know we are 4 people now. Feel free to say hello in the chat if you want. Something I didn't mention yet as well is that the idea is not for me to necessarily be alone doing my little thing here. If you want to join, it's really, you're welcome to do so. You just have to tell me either in the YouTube chat or on Telegram. I'm just going to share again the Telegram in case it's useful. And I can then send you a quick link and you can join me on stage. So if you want to have some more richer discussions, if you want to ask questions or if something I said was wrong or not really clear or something like that, or you want to add precisions, you can do so in the chat, or you can also join me on stage if it's easier to convey your message. I see we have Amboss Technologies in the chat. So for example, Amboss, if you're still there when we cover the, so I guess it's just over. If you're still there when we cover the new Amboss Lightning subscription service, you can feel free to join me on stage to cover what I miss or something like that, if you would like to. And we can, if you are a schedule and you don't want necessarily to hang out during the whole session today, we can also start with Amboss new liquidity subscription if you want. This way you can maybe join me on stage if you want to maybe explain to the 4 people we are now what this is exactly. So as you wish, we can do this in this order if you'd like. So yes, that's basically the program for today. So maybe actually we can start with liquidity sourcing. This way, if you want to chime in, you can do so. Great. So I don't have slides for this part. So I'm going to just head straight down to your blog announcement. So basically, for people who don't know Amboss yet, so I don't know how the Amboss people would describe Amboss, but I think you can say that it's a data company for Lightning. And so if we go to Amboss's website, you can see what is the main front end for Amboss. And basically, it's a Lightning Network Explorer where you can find basically any public Lightning node by the alias, by the public key. You can see, for example, some data here. So of course, it's often the same big nodes that are in these big movers sections. For example, if we take a look at async, well, you can see lots of stuff, actually. You can see some historical data. You can see channels list, a channel map, which I find quite useful to quickly spot big channels. So with async, it's really not that readable in the on the tail here. You have fee report, which is great as well in order to get a quick assessment of what kind of fees this node charges if you're looking to open a channel with a node, for example. This kind of stuff. Amboss also has the Magma Marketplace, which is a place where people can advertise that they are eager to, let's say, lease liquidity to other nodes. So basically what you can see here is a list of nodes who advertise that they are ready to open a channel to you with inbound liquidity if you just agree to pay the fees that they ask for. And so you can, of course, filter by size, because depending on what kind of volume you're expecting. And on the flip side, it's also a great way for people who want to sell channels to earn a yield, so to say, on their Lightning liquidity. So that's the sell channels part of the. So you need to be logged in. So that's one of the caveats with Amboss. You need to have an account for a lot of stuff, but I think it's understandable because you need to build some reputation when it comes to advertising liquidity that you have for sale. So that's basically up to 1 or 2 weeks ago. That was basically the prominent way you could get liquidity from Amboss. You could either, if you wanted to dig yourself, you could try to find good peers by using by exploring around. For example, you could click on the Bolts node. You could see what were some big channels that the Bolts node had. Maybe try to find some nodes that aren't the usual suspects. For example, if you want to increase your resilience, maybe you don't want to use only async. Maybe you want to open a channel with some other big node or even a medium node, for example. This kind of stuff. Or you could, if you required inbound liquidity, you could use the Magma Marketplace to buy channels. But once again, it might be a bit cumbersome. And for example, if you take the example of some business that just wants to sell stuff, so goods or services using Lightning, maybe it doesn't really make sense to have them go through this kind of interface because it's a bit hard to understand everything, especially if it's not your core business. And so that's why Amboss launched their liquidity subscriptions service, where basically, let me share what it looks like. I think we'll have some details. Maybe not. If I click trade today, yeah, it asks to log me out. Are there any? Okay, so if just offer from Amboss is here, maybe do you have some snapshots we could use? Because basically the idea is that instead of having to manually select channels, you can buy a subscription through Amboss liquidity subscription service. And basically what you buy is you buy liquidity for a given volume that you're expecting to need. So basically a volume as in inbound liquidity volume. So for example, you expect that you are going to receive, I don't know, you expect you're going to receive $10,000 in equivalent in Bitcoin on Lightning. And then you can just specify this volume. You can say that you want to have this for the next month, and it will auto-renew, of course. And then it's you just have to pay one invoice, which corresponds to 0.5. Great, thank you. To 0.5% of awesome. So we have a screenshot here, which is great. Thank you. So you just specify revenue capacity, basically what you expect to be receiving this month on Lightning. You'd have to pay a 0.5% transaction fee on this volume, on this expected volume. And then you can subscribe. So for example, for $4,000 per month, this 0.5% is $20 per month. And then with this recurring buy, with this subscription, what you receive is automatically having channels open to your node, sourced from a variety of LSPs or liquidity providers. Let's say, yeah, let's keep it completely open. Liquidity providers, sourced, for example, through the Magma marketplace. But you don't have to worry about finding them yourself. This part is automated by Amboss, because as I mentioned earlier, Amboss is a data company on Lightning, and so they have some analytics with that use different data sources. For example, gossip data. I think they also use more private data that some nodes communicate to them in order to, and so that's how they built something we covered a few weeks ago, I believe, about, so they have a graph where they can represent the payment probability, the probability of a payment of a given size to reach a given node from any node on the network. And so basically with this kind of data, of statistics, they're able to assess at a given time which liquidity providers provide the best reliability, e.g. the best probability of success for payments. And then they will automatically open and renew channels with these providers to your node. So this is basically the product. Of course, it's not necessarily for hardcore Bitcoiners who really want to manage channels for themselves. So for example, it's not necessarily for Bitcoin or Lightning companies, but I think it's really useful for businesses that don't necessarily, for which the core business isn't Bitcoin or Lightning, as they don't just want to sell stuff with Lightning, basically. And so for this kind of use cases, I think it's really useful to have this kind of tool, because let's be honest, I don't expect someone whose core business is not Lightning or Bitcoin to actually use something like Magma, where you have so much stuff to figure out before you can start understanding what you need to do. So I hope it was a fair summary, Jesse. Feel free to open if you want to add some stuff. So I see you just shared something else. We aim for smart buying. Yeah, so basically also, there is this dimension, you're right, of optimizing the cost of your channels, basically getting the most receiving capability for every dollar that you spend on liquidity providers, basically. So yeah, this sentence I think is interesting. When purchasing from multiple LSPs, we can evaluate the cumulative effect of each purchase, not just more liquidity. Okay. I'm not sure to understand exactly what this all means, but yeah. Okay, if you want, to just give some more precisions, and of course there's the AI part where, so I guess you train this AI based on Amboss data that Amboss collected, and since the simulations are the graphs that we talked about this a few sessions ago, and so they are, of course, they take some time to compute. That's, I guess, quite expensive. Whereas with reinforcement learning, once you've trained your recommendation engine, things get quicker and they can give you estimations more quickly. Great, awesome, great stuff. Thank you very much. I see you're typing. So I'll wait for. Nope. All right. Okay. Thank you very much, Jesse. Once again, feel free to, if you have some time to open. I hope it was a decent summary of what you're trying to achieve with liquidity subscriptions. But yeah, so I think we can agree that going from this to what you showed just here, yeah, I think it's the way forward for at least companies that are not Bitcoin and Lightning centric. And I hope we can achieve the same UX with maybe more decentralized, less company-oriented solutions. This way, even the hobbyists and all these kind of people can, or even smaller businesses, can get access to easier liquidity sourcing on Lightning. Awesome. Thank you very much, Jesse. And so speaking of liquidity sourcing, there was another interesting project that caught my eye on Nostr last week, which was this project Pub LSP from Small World LND, which is basically the idea is basically an open source command line tool that basically liquidity providers can use to advertise liquidity offers over Nostr. And so then he expands on how it works basically. So there's some, as always on Nostr, some nice event kind that client can pool and on which liquidity providers can publish. And then through basically Nostr DMs, you can, as a client, you can contact any liquidity providers that you found through these events and coordinate a liquidity purchase. Yeah, so that's what it says here. And so as an LSP, of course, you need to have this running. As a client, you can just run this Pub LSP. You can just run it once when you're trying to find a new channel. But as an LSP, you need to be running this Pub LSP tool basically continuously if you want to receive incoming requests. And you can also post liquidity offers. And so the daemon will listen for liquidity. On the LSP side, the daemon will listen for liquidity requests, send invoices in response to those orders, because of course you are selling your liquidity. So you need to be able to send invoices, check that the payment was received. And once the payment was received, you can send funding transactions to the mempool once you've been paid. And update, of course, the customer on channel funding details, and then release the payment pre-image upon channel payment, upon the channel open. So you basically you're asking for to be. It's a bit like a lot of LSP do that. For example, if you want to try this flow out, you can check on LN Big. So basically, they will present an order invoice to you, and only once you've paid will the channel be open. And so I think it's definitely interesting to be using Nostr, because I see that as being. So we just saw Amboss' offering, which is very business oriented. And now there is this Nostr alternative, which is really more P2P, plebs, let's say plebs oriented. And I think we really need both. And maybe even more, we need probably some kind of further aggregation around all that. So yeah, it's definitely interesting, and I think we will probably take a closer look at it in a later session. let's get back to the slide. And let's maybe switch to our main subject for today, which was Lightning payment privacy through proxies. And for this one, I have slides, which is great. And so last week, prolific developer SuperTestnet, so if you don't know SuperTestnet, is publishing a lot of prototypes, let's say, so proof of concepts regarding a lot of the time it's around Lightning development, so like the Lightning protocols and things like that. And so if you want to take a look at their GitHub account, I linked it here, and yeah, you can see there are a lot of stuff. Usually it's really proof of concept, so a basic UI, and a lot of the times all the logic also fits into the HTML page, which is great because it means that it's actually quite easy to run this kind of stuff in a lot of different environments because it's running on the web. It means you can run it quite easily in mobile and things like that. And so he released Lightning Blinder. You can find the repository following this QR code or this link, which is a tool to obfuscate a payment recipient and potentially also the sender. And so what's the issue with Lightning privacy? Because sometimes we hear that Lightning is great for privacy, that it's better than on-chain Bitcoin for privacy, things like that. SuperTestnet himself will often have some heated debates on social media with Monero enthusiasts, for example, around the privacy benefits of Lightning versus Monero and things like that. But one thing is sure is that when you are using a third party to facilitate your payment, so a third party can be, for example, a custodian like Wallet of Satoshi, for example, or CoinOS, or if you are using an LSP, so for example, let's say Phoenix, or let's say Zeus Pay, I think it's the name of Zeus's LSP, or Breeze, then this third party can learn some degree of information about your payment, and the degree, the magnitude of what they can learn depends on exactly what your relationship with this third party is. For example, custodians, it's really like a bank. They need to be aware of everything that is going on in the payment in order to be able to actually make the payment on your behalf. So for example, when you're using Wallet of Satoshi knows who you're paying. It knows that it's you paying them. It knows the amount and all this kind of stuff. When you are using an LSP, things are a little bit different, and it actually depends on the LSP. Most LSPs, what you have, the kind of relationship you have with them is that you have a Lightning wallet on your device, so for example, on your mobile phone, and you compute the route to reach your destination on your device. It's not the LSP that computes the route. So this means that they don't know who you're paying. They are just the first hop of your route. But usually what they will know is that the payment originates from you, because usually when you use an LSP, it means that you are using a mobile device. So you have a Lightning node on a mobile device. And so this Lightning node will be off most of the time, and it will only come back on when you want to actually make or receive a payment. And so they can just basically consider that when they receive from you an HTLC, so request to route a payment, the payment actually originated from you. So that's not something that they should know in theory when you look at how the Lightning Network Protocol works. But in practice, since they can see that you're offline most of the time, and when you come online, usually it's because you are trying to send or to receive. If they receive an HTLC from you, they know that you are actively sending funds to a destination. So they know that the user, you, are the source of the payment. And so the only thing that maybe is blinded from them is the actual destination of the payment. But once again, that's something that they can infer to some extent. For example, if given the fact that a successful payment usually follows a quite small route, they can know that there are not many nodes between them and the destination. And so they can try to reduce the portion of the network where the destination actually is on the topology of the network. And sometimes it can be enough to kind of infer who the destination is. Sometimes it's not enough, or they have a set of potential destinations, but they don't know for sure which it is. But still, they can guess some things. And then you have some LSP models where the LSP is the one doing the route computation. So, for example, it's the case for Fanis and async, because they are using something called trampoline payments, where basically the LSP is in charge, the LSP node is in charge of computing the route on behalf of the user. The idea behind that is that computing a route is not a trivial task, especially on a mobile device, because since the mobile is off, since the Fanis application, for example, is off most of the time, it doesn't have necessarily up-to-date data regarding the topology of the network. So the LSP must usually provide this kind of data. But then if the LSP provides the gossip data, the topological data to the user, they can kind of already do some stuff where they manipulate the data in order to trick the user into sending the funds in a certain direction. So why not straight compute the route at the LSP level instead of letting the user do that? So that's trade-offs. The idea with trampoline is that if there are more than, if it was not just async that was doing trampoline payment, we would have more privacy, because then the destination node could be just another trampoline routing node and not the final destination. But as of now, it isn't really the case. And so what happens is that the LSP, so async, knows that the user is the source of the payment. And because they are computing the route, they know that they know the final destination, because they have to compute a route between them and the final destination. So they know basically everything about the payment, or at least they know as much as any custodial wallet. And so they are, of course, open about that. They are stating this fact in their FAQ, but yeah, it's worth noting that basically that's where we're at right now. And with more and more people using LSPs, because LSPs are great because you retain self-custody of your funds at least, but there are these privacy implications. And so what is SuperTestnet's proposal regarding that? So before that, we are going to take a look at another project that was published before Lightning Glider and is actually deployed to mainnet, whereas Lightning Glider is still, at the MVP stage. So lnproxy.org is you can go to the website and actually actively use it right now. I use it when I need to, for example, send funds from async, or receive, more precisely, funds from someone who uses Fanis, for example. You can use an LN Proxy to try to obfuscate your identity as a receiver. And so it can be useful to obfuscate your identity as a receiver, either from the sender of the payment or from their LSP. Maybe you don't care that your buddy who is sending you a few sats knows what your node's public key is, but maybe you don't want async to know that, for example. And if your buddy is using Fanis, then async would learn that. And how does it work? So first, the user creates an invoice. Here, the user creates an invoice, and the user sends this invoice to the proxy. So the proxy is, for example, this online server here, which you can reach via user interface. Then the proxy will respond with a wrapped invoice. So basically, they take the hash from the invoice, and they create another invoice, but with the same hash, and maybe a different amount, higher amount if they want to charge some fees. The fact that the wrapped invoice uses the same hash as the invoice means that it can be settled with the same preimage. That's the beauty of this system. And hi Theo, welcome. And so since the user in this context created the invoice, the user knows the preimage, but the proxy doesn't. The proxy only created a similar invoice to the one they received from the user. And so in the user's invoice, the hash is visible to the proxy. And so the proxy can use the hash to create another invoice locked to the same hash, but with a bigger amount. And so the proxy gives this wrapped invoice to the user. And then the user sends the wrapped invoice and not the original invoice. So the user sends the wrapped invoice to the sender. The sender will then pay the wrapped invoice. But so the wrapped invoice is paying the proxy, not the user. And so by pay here, we mean that the sender sends an HTLC, so extends HTLCs along the route to offer the payment to the proxy. And so the payment is not settled yet. And so the proxy, when they receive the HTLC, which is locked to the hash we talked about, they don't know the preimage, so they can't unlock the payment. And the only way for them to get the preimage is to get it from the user, which created the invoice, and so is the only one to know the preimage. And so what the proxy does is they will also pay, but this time they will pay the original invoice. So we send an HTLC to the user saying, if you reveal the preimage, the funds are yours. The user who wants to get their money, they will settle the invoice, so they will reveal the preimage to the proxy. And now the proxy has the preimage, and of course they want to get the funds that were promised to them, and so they will in turn reveal the preimage, and so settle the wrapped invoice. So here the arrows are between sender and proxy, but of course there is a whole route between the two of them, and everything here happens as usual on Lightning. We are extending HTLC, and then we are, sorry about that, we are settling HTLC from the end up to the beginning. So yeah, it's great. This way the user can create an invoice, get paid trustlessly, but the sender never learned, to the sender it appeared as if they were paying LN Proxy and not the user. And only LN Proxy knows that a given invoice originated from a given Lightning node, a given user. So you are hiding, obfuscating information from the sender, but on the other hand, you are maybe revealing some stuff to the proxy. So yeah, there is a trust assumption here maybe, but that can be mitigated through proxy decentralization and things like that. Great, and so that's LN Proxy, which, as I mentioned, has been available on mainnet for I think a few years now and working quite reliably. I know that peer-to-peer on-off ramp like RoboSats, for example, use LN Proxy as well behind the hood automatically when you receive on Lightning on RoboSats. RoboStats automatically blinds the invoice through LN Proxy. So yeah, really great stuff. And so Theo says that it's kind of a blinded pass, but with a proxy that knows a bit more. And at least it's simple enough. Yeah, exactly. And that's why that's what LN Proxy says. So here you can see the lnproxy.org website. So here you can choose your relay. I think it will be decentralized a bit more in the future. You can specify a description. You can set your routing budget. So basically, it's how much you are willing to pay in fees in order to have the payment go through. And if you go to the About page, basically what they say about their solution, it's a poor man's rendezvous. So yeah, it's basically a simple implementation of rendezvous routing or blinded path. The simplicity of it means that there are some trade-offs, but at least it works now without having to add stuff to the Lightning protocol and hope that everyone agrees on that. But yeah, basically that's how it works. And so, as you can see here, the wrapped invoice is a hodl invoice. Because it waits for the user to settle it. It's extended. Actually, where is the wrap? No, the wrapped invoice here is a hodl invoice. So yeah, we'll come to hodl invoices a bit later. And now we have a new protocol in town that looks a bit like, if I just hop between the two pages, looks a bit like the one before, but you'll see that it's a bit, sometimes it looks like it's the symmetrical of LN Proxy. So let's take a closer look at how it works. So that's this new protocol is of course Lightning Blinder from SuperTestnet. So here we have basically the same setup with the sender, maybe the LSP, a proxy, and the user. So it's the user that try to obfuscate from the sender and from the sender's LSP. And so this time the user doesn't give the proxy an invoice; it gives them an amount. It says to the proxy, "I want to receive, let's say, 10,000 sats," and then the proxy says sure and gives the user an invoice. So the proxy creates a new invoice. And so this time it is the proxy that knows the pre-image of this invoice. So the proxy creates an invoice for the amount that the user requested plus some amount for the fees that go to the proxy. Then the user takes this invoice from the proxy and creates a wrapped invoice. So as we saw before with LN Proxy, the user creates another invoice that is locked to the same hash than the invoice that the proxy sent to them. And the user sends the wrapped invoice back to the proxy. This way the proxy knows the wrapped invoice, and the proxy right away extends an HTLC to the user paying for this invoice. So the proxy tries to start paying the invoice right away, the wrapped invoice from the user right away when it received it. But for now, the user doesn't know the pre-image, since only the proxy does, because they created the original invoice. So right now, the user can't settle the invoice and get paid. So what the user does is they send the invoice, the original invoice that was created by the proxy and which pays the proxy. They send this original invoice to the sender. And along this invoice, they give the sender some way of reaching them, because later we will need the sender to contact the user out of band. So they give the user an invoice and they give them, for example, I don't know, a Nostr public key or something like that the sender can use to contact the user later on. When the sender receives the invoice, they can pay the invoice as usual. And so the payment propagates and things like that, and it reaches a proxy. But now the proxy, of course, they created the invoice in the first place, so they know the pre-image of the invoice. So they will settle the invoice, they will reveal the pre-image, the invoice will be set, the payment will be settled from downstream to upstream as usual, until it reaches the sender. And so at this point, the proxy has been paid, they received the money, but the user hasn't received anything yet. And so now the sender just learned the pre-image, and they can send the pre-image to the user using the out-of-band method that was previously disclosed by the user when they sent the invoice. So for example, using a Nostr direct message. They send the pre-image to the user, and now the user knows the pre-image, and so the user can settle the wrapped invoice and claim the funds. So as you can see, it's a bit of the reverse when you compare it to LN Proxy. In LN Proxy, the user creates the original invoice, and the proxy creates the wrapped invoice. And then the user communicates the wrapped invoice to the sender, and so the sender pays the proxy, which then, in order to know the pre-image, because they don't in this context, need to extend the payment to the user and to have the user settle the payment before they can settle it. Here, it's a bit the other way around. The user just specifies the amount, and then the proxy creates the invoice. The user then responds with a wrapped invoice, and it's the original invoice that is sent to the sender, which the sender pays. And only once this part of the payment is done, does the sender send the pre-image to the user. And then at this point, the user can settle this second part of the payment. So one thing that you can see quite quickly is that if you compare the both, LN Proxy is atomic in the sense that either the funds reach the end user or nothing happens. And it's something that we want to have because it's one of the core properties of Lightning is that of payment routing on Lightning is that routing is atomic, and so either the funds reach the final destination or we just cancel the payment altogether. Here it's not the case. What could happen is that so the user requests an invoice from the proxy for a given amount, the proxy sends the invoice, the user wraps the invoice, sends it to the proxy extends an HTLC for this wrapped invoice, but the user can't settle it right now, so they send the invoice to the sender pays the invoice to the proxy reveals the pre-image to the sender, and then the sender just stops here and doesn't reveal the pre-image to the user. And so if this happens, then the proxy has been paid, but the user hasn't been paid. So of course now, since the sender presumably wants to pay the user, they will, of course, in this context, send the pre-image to the user in the end. But you can see that, for example, they could have a problem, their connection dropped or something like that, and so maybe they're not able to do it right away. But the proxy, in the meantime, has already received the money. So here, the atomicity of the Lightning payment has been broken through this design. There is also a consideration regarding expiry of the different invoices. What you want to ensure is that, which way is it? Let me take a look. This way, I'm sure to not say something dumb. Yeah, here you go. So the wrapped invoice, which is created by the receiver, must have a higher time lock than the one created by the proxy. And this is because of the following risk. Suppose the receiver invoice expires after 3 days and the proxy expires after 10 days. Okay, so let's take a look at what happened then. So this wrapped invoice expires after 3 days and this invoice expires after only 2 days. Then, yeah, what the proxy could do in this context, if that was the case, is they could wait for the wrapped invoice to expire. And then only once the wrapped invoice has expired would they settle the original invoice, since the original invoice is not expired yet. And then even if the sender sends the pre-image to the user, it does not help the user claim the funds because the wrapped invoice expired already. And so that's why it's important that the wrapped invoice expires after the original invoice and not before. So you need to pay attention here and be careful in order to be sure that the proxy can't steal on its own from the user. And so with this careful consideration regarding time lock, then there is still this trade-off that atomicity is broken, but otherwise it's still a trustless flow as long as the sender doesn't try to screw the receiver. But basically, in most cases, the sender wants, I think in all cases, the sender wants the money to actually reach the user. And even if you're looking at, for example, some interaction between a merchant and someone who sends money to them to buy stuff, then the sender really wants, for example, the money to reach the user, because else they would have paid, but for nothing, because the merchant didn't get the money, so they're not going to provide the goods or services. So you have this trade-off here that it's not atomic, but other than that, it's pretty much the same trade-offs as LN Proxy. And so in theory, Lightning Blinder can also be used to blind the sender of a payment by having the users of LSPs, for example, themselves act as proxies. So for example, here, let's say that the proxy here is a Phoenix user, for example. So yeah, you have to make you use your imagination a bit here. But so let's say you want to pay someone as the sender. Basically, it will be a little bit like it's the other way around. You want to instead of going me, my LSP, and my recipient, what you will do is you will go me, the proxy, my LSP, and then my recipient. And so yeah, let's go to the spot where they explain that. So the protocol, as described above, fools an LSP into thinking one of the users is sending money to person A when they are really sending money to person B. But there is another way to use Lightning Blinder. Have person A, who I have decided to call Quincy, right, run the proxy. So LBC is a Lightning Blinder coordinator, so basically it's a proxy software. So suppose a user of Lightning Blinder, Robert, picks Quincy as a proxy, and suppose the man named Paul wants to pay Robert through Quincy. So the payment you have is Paul, Quincy, Robert, where Quincy is a proxy. When Robert receives the payment from Paul through Quincy, Paul's LSP thinks that Quincy is the recipient. So Paul sends to Quincy via their LSP. And so the LSP thinks that Quincy is the recipient, but the real recipient is Robert. But that's what we saw up to this point. But that's not all. Quincy here is using an LSP too. And Quincy's LSP still will think that Quincy is the sender when he's actually forwarding a payment from Paul to Robert. So not only do you hide Robert, the real recipient, but you also hide Paul, the real sender. So it's a bit like the Russian dolls here. And so basically, the idea is that inside this proxy circle here, you have proxy and LSP again. And so now you are, as a user of the LSP, when you act as a proxy, the LSP thinks that the payment originated from you if they use their traditional heuristic that a payment that routing request that came from one of their clients must originate from this specific client, which is a common heuristic, as I mentioned earlier, for LSPs. But in this case, the heuristic is wrong because the payment actually came from the original sender. And so that's a way where Lightning Binder can also somehow obfuscate senders as well. So here the idea is different. The idea is that you try to break the heuristic that LSP rely on to be able to tell who the sender is. And so if many users of LSPs do that, then you basically have plausible deniability when it comes to whether you were the origin of a payment or not. And so now the LSP can't be sure that when they see a payment from you, it really originated from you, or if you're just passing it around as a proxy. So of course, having this kind of stuff requires the proxy code to be easy to run on top of a wallet that uses an LSP, which seems to be kind of achievable, as I mentioned earlier, because since the prototype that SuperTestnet presented runs in an HTML file, it's basically JavaScript, and it can run probably everywhere. You just have to maybe sometimes tweak, make a copy of a tweaked copy of an application in order to cram this proxy stuff in there, but it's usually doable because self-custodial application wallets, Lightning wallets, are open source. And then you also need an efficient coordination and notification mechanism because most of nodes that rely on an LSP are mobile nodes, and so you need a way to wake the application, the Lightning wallet that is on the phone, to wake this wallet up. You need to have proxy discovery as well. You need for this kind of proxies to be able to advertise that they exist. So I think, yeah, there are still lots of challenges when it comes to, I don't know, people who use Fanis being able to run this easily on their phone and having their phone wake up to proxy payments and things like that. So now maybe Fanis could themselves could maybe add this kind of functionalities if they want to improve users' privacy. But yeah, that's some additional work, of course, which is, I think out of scope for them. But yeah, so that basically the core ideas between Lightning binders. And so here, if you want to have a quick comparison between the LN Proxy and Lightning binders, it's basically what I mentioned earlier. Things are a bit like reversed. The initial invoice is created by the user in LN Proxy and by the proxy in Lightning binder. The wrapped invoice holder, so the one who has a wrapped invoice and must wait for the wrapped invoice to be paid. In an LN Proxy case, it's the proxy, and in Lightning binder case, it's the user. And as I mentioned, in LN Proxy, the payment is atomic completely, like in the vanilla Lightning network, whereas on Lightning binder, it is not. And the final difference, in my list at least, between the two of them, which I think motivated the creation of Lightning binder to some extent, is that LN Proxy is not really implementation agnostic as of today, because it requires other invoices. So here, when the proxy creates a wrapped invoice, it needs a Lightning node implementation that is able to create such wrapped invoice, which are also called other invoice, and basically are invoices where you create them, you already know the hash, and you create an invoice locked to this hash, and at some point you will settle the invoice, but not automatically. You have to tell the node that, oh no, I know the pre-image. You didn't, because with a classical invoice, basically the node already knows the pre-image because the node created, computed, found, selected the pre-image at random. And so it keeps this pre-image in some kind of database, and then it will automatically settle the invoice when it comes around when the HTLC comes in. Whereas with wrapped invoice, basically the idea is that you don't know yet the pre-image, and you will learn it later, and then you will settle the wrapped invoice. So that's why there is some. That's why wrapped invoice are some kind of hodl invoices. And so you need for the proxy, you need to be able to handle this kind of hodl invoices. And as of today, only LND supports hodl invoices. So I didn't check that. This is from SuperTestnet motivation. So I didn't check whether it's true or not, but yeah, I believe him. Whereas on Lightning Blinder, there isn't such requirement on the proxy, because the proxy just deals with standard invoices. So yeah, that's another big difference, and that's what could make it easier to run Lightning Blinder proxies, basically in a lot of situations, and even on mobile wallets, for example, because you don't have to handle hodl invoices. And now to some Polar exercise. So we are not going to do the exercise now, but I just wanted to present an exercise to you, which basically is on this exact topic. So let me just find it. Yep, okay. So basically here you have the README, and I will share the QR in a moment so that you can flash it. And so this is the context that I just mentioned. And so the idea is using Polar. So we have done it a few times already, but using Polar, the idea of the exercise is to design a Polar network with 3 or 4 nodes. So one sender, one LSP, which is optional. It depends on, it's not absolutely necessary to have the LSP. One proxy and one receiver. So the minimum is 3 nodes. You need a sender, a receiver, and a proxy in the middle, and you can add an LSP to the mix. And so the goal of the exercise is to demonstrate basically how LN Proxy and then how Lightning Blinder work. And so, for example, you can write a script to illustrate how the proxy can obfuscate the receiver node identity from the sender and the LSP, if any. And you can use the same Lightning package that we used in previous exercises that we've done, for example, the pre-image stealing exercises, because this package has a create hodl invoice method, which will not try to settle an HTLC automatically when it arrives, because the node basically doesn't know the pre-image at first, doesn't necessarily know the pre-image first at first. And so what's interesting is that when you create this hodl invoice, we can see it here in the example, you don't need to have the secret, which is kind of the point, and you can create the hodl invoice with just the hash of the secret, which is the hash of the invoice. And so using this create hodl invoice method, you should be able to recreate basically how LN Proxy works. And then there are a few questions for you to answer as you do the exercise. But basically, it's, yeah, we've also covered it a bit here already. And then you have basically the idea to do the same with Lightning Blinder, maybe in a different file. So, you know, for example, when we did the pre-image stealing exercise, everything was in one file here. And so basically here you can, if you want, you can separate both exercises into different files to keep things more, to keep things tidy. Great. And so the idea is that if you want to take a look at the exercise and try to do it with Polar, please do. I will share again the QR code so that you can easily find the repository. You have a link here as well. I will share the slides. And I'd like to propose to people who are interested to try to have a conf call, a meet, like some Google Meet call next week, where we can take a look at the exercise, see maybe what was difficult about it and things like that, and try to propose some solution together. So it would be same time. It would be next Tuesday at 6 CET, so Central European Time, Paris time, basically. So yeah, feel free to take a look at this in the meantime, and we'll take a look together in 1 week. Great. And now to the last subject of today's session, which is a nice little tool that Elsirion developed. So Elsirion is one of the great minds behind Fedimint, notably. And so he created, so what I think he called it LN URL POS, which is, as the name implies, point of sale, not a proof of stake, a point of sale. That work, you just have to input a Lightning address or LN URL string, and you can then start using it. So, for example, if you're a merchant, you have, I don't know, an Albi Lightning address, for example, and you can use the web app easily to receive payments. And so maybe I can just do a quick demo. So let me grab the link here. Great. So for example, I have a stacker.news Lightning address, which is Fanis at stacker.news. I can hit continue here. It will fetch all this kind of stuff. But you can see here in the website URL that everything is passed as a parameter, which is great. For example, if I want to go back to a Lightning point of sale with this address here, I can just reuse the same URL. And so if I just go to my Stacker News account as well, I think it's, yeah, let's do this way. Let's have both things. So if I go to notifications, you can see that I did a test earlier. And so what is great with Stacker News is that when it comes to sats that you receive on your Stacker News Lightning address, it's self-custodial. So you need to create a connection between Stacker News and another wallet. And for example, here, Stacker News is directly connected to my LND node through Nostr Wallet Connect, which means that when I pay to Fanis at stacker.news, Stacker News will forward the payment to my LND node. So of course, there are still some trust assumptions. Basically, you trust the Lightning address server, so in this context, stacker.news, to, when requested, provide invoices that pay your node and not theirs. So it's best to have your own Lightning address server, your own LN URL server. But yeah, for small amounts, you can also use someone else's. And I guess it's fine. But you have to have in mind that there are some trade-offs here as well. And so if you remember, here I input just my Lightning address, Fanis at stacker.news. And so now that's what I would see as a merchant, for example, in some festival or at a restaurant or things like that. And so now I want to charge a customer. So I will, for example, write 1,000 sats. And then I will hit request invoice. And so it will reach Stacker News, which will in turn reach my own node at home, and get an invoice for 1,000 sats from my node, which is sitting at home, which is great. And now you can see that all the LN URL part is handled by the pos.lnaddress.org website. So for example, here the QR code that is shown is not a QR code from that represents LN URL payment code. It's really an invoice, a Lightning invoice. So basically, you can pay this with any Lightning wallet. Your Lightning wallet doesn't need to support LN URL at all. And so here I will use Fanis, for example. I will try to pay. I hope it works. And I will hit pay. And it worked. And here you can see that the payment was received. And if I refresh the notification page on Stacker News, yeah, you can see that the payment went through. And so Stacker News takes a 10% cut. Also, as I think it's also as a security mechanism as well to avoid some kind of schemes. But so out of the 1,000 sats, 100 went to the reward pool on Stacker News, and 900 was sent directly to my LND node at home. And one thing that is really important, the very interesting thing about this point of sale, is that here as a merchant, without having to look at my wallet, I showed my wallet here for the sake of the demonstration, but I didn't have to. Without having to look at my wallet, I got a confirmation here on the point of sale that the payment was received. And this is what is especially interesting about this, this point of sale. So if I go back to my slides to explain a bit more what I mean by that. So here, you can see basically the classic LN URL pay flow. So here you have Alice, which is the person who sends the payment, and here you have Bob, so for example, the merchant. What usually happens is that Alice gets either, let's say Alice gets a Lightning address, so the Lightning address just, or LN URL string are basically the same thing, it just adds one hop, one additional query in the middle, but it's basically the same thing. And so what Alice will do is that with the Lightning address, she gets basically a URL that she can call to get some details about how she can pay. So basically, she sends a request to this URL, and the server, so in my example, it was stacker.news, will respond with some details, such as what is the minimum amount that can be sent, what is the max amount, some metadata, for example, some picture, and then the important part, the most important part, is this callback URL. And then Alice's wallet will, so for example, if my Lightning address server provided a min and max, will use this information to show to Alice what is the min amount she can send, what is the max amount she can send, and stuff like that. And then Alice will be prompted on her wallet to pay, to decide the amount and things like that, to provide a description if she wants to. And when she hits pay on her wallet, what happens behind the scenes is that Alice's wallet will send a callback. So we'll basically send a GET request to another URL, which was the URL specified in the first message from the server. And when the server receives this request, it will turn to my Lightning node at home. So in our case, it was my LND home and my LND node at home, and request an invoice for the amount that Alice specified. Then my node will respond with an invoice, and the server will return the invoice to Alice. And then Alice, now she has an invoice, and she will pay on Lightning, so directly to my node. This doesn't go through the Lightning address server here. This goes straight from Alice's node to my node on Lightning. Maybe there are some nodes on the route, but it is completely independent of the Lightning address server. And then the invoice settles. And so Alice sees on her phone that the payment went through. The only problem with this setup here is that Alice can show the merchant that she received, that the payment went through and that the merchant was paid, that the invoice was settled, but the merchant can't just know for sure that the payment went through without looking at their own Lightning node. And so they need to have access to the Lightning node to be able to see if the payment went through. And so that's what this tool fixes. And it uses something called, let me find it, I think I have it here. It uses another part of the LN URL spec specification, which is called verify. And so basically with verify, the idea is that you can in the callback response, so at this point here, sorry, in the callback response, the server also gives a verify URL, which the client can use to check if a payment, if the payment succeeded or not. And so here, in our little example, actually what happens is that Alice is not directly, so I'm just going to copy it actually in order to not mess with my my slide. What happened in our example here is that Alice is not directly interacting with Bob's LN URL server. So she's one step away, and instead she's interacting with a proof with Bob point of sale. And so it is a point of sale that is interacting with the LN URL server actually. And so so here the merchant inputs, so this part basically is done at the start. And when the merchant, so when we did my demo, we started basically at this point here. The merchant inputs the amount in the point of sale. The point of sale queries the callback URL of the LN URL server, asking for an invoice for this amount. The LN URL server reaches the node of the merchant, asking for an invoice. The node responds with an invoice. And then the server, so basically what in this context, the server is connected to the node in a way that with sufficient permissions to be able to ask for new invoices and to ask about the status of an invoice. And so you can manage this kind of permissions. So for example, if you use Nostr Wallet Connect, you have quite fine-grained permissions that allow you to specify if you want to give read access to invoices to a server that can connect to your node. And when it gets the invoice, the server will send the invoice to the point of sale. But in the callback, there will also be another callback URL that the POS can use to verify if the payment was done. So here you have not just the invoice, you have also as well the verify callback URL. And so Alice pays here, it's actually Alice that pays on Lightning to the user. So she pays, here she pays an invoice. She doesn't pay, so let me add this as well. Here, what happens is that Alice can scan the invoice from the point of sale. So here, I'm doing this live. The point of sale displays the invoice to Alice. Alice can pay the invoice on Lightning. So this goes through Lightning. That's why it's orange. And then Bob settles the invoice. So this goes to sorry, this goes to Alice directly. But at the same time, once the invoice is settled, Bob's node will also send a message to the LN URL server saying that the payment was successful. And then the point of sale knows this verify callback URL, and so they will poll this URL repeatedly until they get a response from the LN URL server saying whether the payment was successful or not. So maybe the payment wasn't successful and they'll get an error message, or maybe the payment was successful and then they will know that the payment was successful, and they will be able to display to the merchant that the payment was successful. So I think it's great because it means that as a merchant, you can have basically some little point of sale that you don't need to trust. The great part is that you only need to trust the Lightning address server that you're using, but the point of sale is just sending money straight to. Actually, you need to trust them a bit. You need to trust them to display up-to-date news, not up-to-date news, but to display the real stuff, to display the invoices that the Lightning address server responds with, to display accurate information about the payment status. But you can just, it's open source, you can just run it locally. And so you don't need to trust anyone. And you can receive to a Lightning address and see in real time if I do another test with, for example, 100 sats. I can request an invoice again. I can, so that you can see all the, you can see here all the, let's do with 1000 sats. You can see all the steps. I request, so I can change the unit as well, which is cool. I request invoice. So the point of sale sends a message to the Lightning address server requesting an invoice for the amount 1000 sats. The Lightning address server reaches my node asking an invoice for this amount. My node responds with an invoice. The point of sale, the Lightning address server sends the invoice along with the verify callback URL to the point of sale. The point of sale displays the invoice to the customer, for example, if we're in a merchant situation. The customer can scan the invoice. So it's a Lightning invoice, traditional one. The customer pays. And when the payment arrives in the node notifies the Lightning address server that it received the payment. The Lightning address server then, and then the point of sale, when it queries the callback, will learn from the Lightning address server that the payment was indeed successful. And so the merchant can check live that they received the payment, that they don't have to either open their own, open a wallet app where they have their access to the Lightning node. They can just use the point of sale. And if I refresh this page again, we can see another 900 sats payment went through. So yeah, it's really great. And all you need to do is put a Lightning address or LN URL string here, which is really great. And it doesn't change your trust assumptions. Basically, if you already trust the Lightning address server, you can use this without changing your trust model, which is great. So yeah, that's basically it for today. Feel free to ask any questions. So as a reminder, I presented quickly some little Polar exercise that is on the topic of using proxies in order to improve payment privacy on Lightning. The idea, if you can find some time between today and next Tuesday to take a look at the exercise, try to see if you can find a solution using Polar and writing a little script using the Lightning package by Alex Bosworth, for example, in JavaScript. It would be great. We are going to take a look at this together next week anyway, but if you have already taken a look yourself, it's better. And so it will be not on YouTube. It will be in a more private conference call using some alternatives to Google Meet that Plan B network self-hosts. Sorry. So this way we're not sending data to the evil Google. And if you want to join the Telegram group, you just have to follow this QR code. It's where all the stuff happen, and it's where you can, for example, if you want to take a look at the exercise and try to solve them, it's where you can easily reach other students or me to ask questions. For example, if you have trouble installing Polar or things like that. Awesome. Great. Thanks a lot to everyone for joining. I think we almost hit 10 watchers at the same time today, which is great. So thanks a lot for joining. Thanks, Theo. Thanks, Turbo Exchange. Thanks, Yulu. Thanks, Jesse. I don't know if you're still around, but for joining us in the beginning and providing some nice screenshots for the part where we talk about Amboss Lightning subscription. Great. So I see you on the Telegram group. Also next Tuesday, hopefully, if you want to join us in this more private session where the idea is to encourage more participation by not recording everything and not having things being available online later. The idea is that, it's more easy for you to discuss with me if everything is not recorded. So yeah, see you on the Telegram group. See you next week. And thanks again for joining us today. Bye-bye.